Good morning, students. Welcome to the first video of choosing not to use drugs, alcohol, vape pens, tobacco, spit tobacco, and inhalants. If it seems like I'm going quickly, that's because I am. We only have 15 minutes. Partnership for a Drug-Free America ad. When Miss Marguson and I were growing up, students, this is the kind of education, this is the kind of advertisement we had, anti-drugs. We really didn't know what happened in the brain, and so this guy said things like this.
Is there anyone out there who still isn't clear about what doing drugs does? Okay, last time. This is your brain. This is drugs. This is your brain on drugs. Any questions?
My question is, why do you have to make me feel like I'm stupid? So we didn't have the science to know. We knew that drugs were bad for the brain, but we didn't know why. We didn't really know how. We just knew that drugs turn brains into fried eggs. So advances in brain imaging have led to a new understanding that this is indeed your brain. This is a brain scan published in 2007, so this is not even latest technology. You can see the bright parts in the deep part of the temporal lobe are the parts of your brain that are constantly involved in making sure you're safe, scanning the environment, paying attention to things that are important, ignoring things that aren't. These tiny little spots of black are little bits of what are called ventricles that are actually spaces in your brain, holes in your brain that have cerebrospinal fluid in them. So those little black spots right there are normal. A little bit of green activity going on here and there around the brain, but mostly blue. This is a normal brain. The brain scans here are your brains addicted to, or not your brain, but somebody's brain addicted to methamphetamine, alcohol, heroin, and cocaine. As you look at these brains, look at that middle part, the part that's concerned with knowing what's going on in our environment, knowing if we're safe or not, the part that regulates our emotions. Those parts are significantly impacted in function. Then look at all of the black. The parts of the brain that either are gone, fried like an egg, or are lacking completely in their ability to function in all four of those brains. It's really shocking. Okay, so that is important to know. We know that drugs drastically affect the function and the structure of the brain. Moving right along. This is a pie chart that shows the number in thousands of Americans aged 12 and older. What it tells us is that most Americans who are addicted or abusing a substance is alcohol. All right, at this point, at the point that this was published, 18,658,000, because the pie chart is the number in thousands. So, oh my gosh, almost 3/4 of the pie chart taken up by alcohol. Marijuana comes in next. My inference is this number is bigger, more than 4 million people now, because marijuana is legal in so many states. And then the point of this is that the things that we think of when we think of drugs, like cocaine and heroin, relatively few people use them as opposed to the things that are legal. What's not on this chart is tobacco. And I'm not going to tell you the estimated number of people who use tobacco. I want you to think, is it more or less than 18 million in the United States, or coming up on 19 million? I will get back to that later. Okay, this is a little review slide about neurons. These are the nerve cells in your brain. A quick review, message comes in to these dendrites, goes through the cell body, bounces down the axon to the axon terminals of this neuron. Then there is a space between these two neurons. It's tiny. It's called a synapse. And the neuron with the message blasts out neurotransmitters into that space. And then this next neuron says, "Oh, thank you," and scoops those neurotransmitters up. And they may be a message to pass on what's going on, or it may be a message to stop whatever impulse is happening. So for example, if you're raising your hand and waiting for the teacher to call on you and the teacher calls on someone else, you put your hand down. So that would be a stop message. Or the go message is I'm going to put my hand up. Okay, so that happens all in that synapse right there. And then the message is passed along into the next neuron, its cell body, its axon, and so forth. Students, addiction happens with neurotransmitters. So drugs mess with your neurotransmitters in that little space between brain cells. All right, that's the review. More on that soon. So the go mechanism in your brain is all about keeping you alive. The go mechanism in cave people was about getting food, having a safe place to be, and then having sex. Food and sex are two big drives of the go mechanism. We are animals, just like any other animal in the animal kingdom, and all animals have three purposes, or three main drives, three things that motivate them: to seek pleasure, to avoid pain, and to do both of those things as efficiently as possible, to be as lazy as possible. Okay, so the go mechanism is the deep, deep, deep part of your brain that says, I'm hungry, let's get something to eat. And then when you eat, you are rewarded with a little blast of the neurotransmitter, it's called dopamine, that says, oh, that was good. Sex is the same thing. We are driven as humans to have sex. Sex is pleasurable. That's one of those things, to seek pleasure, to avoid pain, and to do both as efficiently as possible. So the go mechanism says, having sex is a good idea, but I hope you learn in the human sexuality unit that at your age it's not a good idea for so many reasons. Anyway, in females, the go mechanism is fully developed by age 14 to 15, and in males, age 15 to 16. This is also the mechanism that would be at work when someone says, what if we jump from the roof to the trampoline? I might even try to do a flip. And the part of your brain that goes, whoa, that sounds like fun, goes, yeah. That's the go mechanism, all right, seeking pleasure. Now, here's what happens inside your brain when you choose to use drugs or alcohol. The go mechanism might say, oh, that sounds like fun. What could it hurt? Someone says, try this, it'll make you feel good. And your brain goes, I want to feel good. All right. So the level of dopamine dopamine is a neurotransmitter, and it is a feel-good neurotransmitter. So right now, I'm making a video, friends. This is not the most exciting part of my day, all right? I do not get a whole lot of pleasure out of making videos. So you're sitting watching a video, which could be even less exciting. And here's our baseline level of dopamine. Our brain is just chugging along going, yeah, we're alive, it's good, nothing particularly fabulous is happening. Oh my gosh. So think about something that has happened in your life that was so pleasurable and you want to repeat it. I think always of rainbows. So, oh, what happened? I lost my smart. When I see the eastern sky dark and the western sky light and it's raining, I think, wait, there's a rainbow, and I love seeing rainbows. So I'll go outside and try to find the rainbow, and be like, oh my gosh, you guys, a rainbow, you've got to come see this. If it's a double rainbow, if it's one of those rainbows that goes call them pot of gold rainbows, that goes all the way from one side of the horizon to the other, that's like best thing. So my dopamine spikes. It's a pleasurable moment for me to see a rainbow. It's such a beautiful part of nature. And here's what it looks like. Pardon my mouse drawing. Oh my gosh. So it probably doesn't even last that long. Let me redo that little rainbow, because I don't walk around for the next 3 hours going, rainbow, oh my heavens, I can't get over it. No, I'm like, oh, you guys gotta come see this. And then the rainbow itself fades pretty quickly. So there's my little rainbow spike of dopamine. It feels good. I'm like, oh, there are good things in the world. Now, when you choose to put drugs into your system, students, the drugs mimic that dopamine response, okay? And it can be anywhere from 2 to 10 times the amount of normal dopamine, the dopamine response that your brain normally has. 2 to 10 times. So when students say, why do people use drugs if they know they're bad for them, or they know they can get addicted? Because as animals, we are programmed to seek pleasure, to avoid pain, and to do both in the most efficient way possible. Drugs fit that bill, unfortunately. So 2 to 10 times. If I go 2 times as high as this, oh, we're about right here. So let's go maybe 3, 4. Let's go 4-ish times as high. The first time you use drugs, you have this huge peak of a dopamine response, and it lasts for a while. Then when you go back down, your brain remembers that experience and goes, whoa, that was awesome, and wants to repeat it. So you use again. The dopamine spike goes up, not quite as far or not quite as long, and when you come back down, eventually, it may not be the second time you use, but eventually your dopamine goes below the baseline. And when your dopamine is below baseline, your normal dopamine level, you are not feeling good. So this may just be a grumpy mood. The person gets high again. That felt so good, I want to do that again. They don't go quite as high or quite as long, and their dopamine level, the brain eventually stops making its own dopamine because it's being artificially put in. Your brain's not going to go to the effort of making any if it's getting it from the outside. And so the high doesn't last as long and the low is lower. Now, I'm going to speed this up, and my high really can't last very long there. Eventually, students, a person starts to use in order to feel normal. They are feeling so badly when they're not using that they're using to feel normal. And as they build tolerance to the drug, a point comes when they will get high and not even reach the point of feeling normal. This is typically when someone does one of two things. Overdoses, trying to use more of the drug in order to get that high to feel normal, or switches to a different drug in order to, again, they're always seeking this high, and it will happen once. It doesn't ever happen like it did the first time again, because your brain immediately starts getting used to it. Okay, this is such a sad progression, students, such a sad progression in how drugs affect the brain. As this person gets further and further into addiction, they start caring less and less about things like food and sex, and they have fooled their brain into thinking that getting high is what is keeping them alive, when that is not the case at all. So they are losing relationships in the process. They are forgetting or not caring about eating. People who are using drugs actually become not interested in sex anymore. Their primary purpose in life is their next high. All right, lastly, there's hope. This is the stop mechanism. So the go mechanism is saying, this is a great idea, let's do this. And the go mechanism is the one that's saying, you got to use it in order to feel normal, dude. The stop mechanism is the one that functions right here. It's the prefrontal cortex part of the brain. We don't share it with any other animal. And it's the one that goes, hold on, if I use, and I'm talking about the first time, if I use, what if my parents find out? What is this going to do to my brain? Hold on, I remember in 7th grade health class, there are big consequences to using drugs in my brain. I don't want to mess with my brain. Could I lose my job? Will I get kicked off the team? What are the things that could happen if I choose to do this? Like jumping off the roof onto the trampoline. The stop mechanism, though, students, in females does not finish developing until age 24 to 25, your mid-20s, 10 years after the go mechanism is fully developed. So there is this 10-year time period where your brain, the deep, deep part of your brain is going, yeah, good idea. And this part of your brain isn't developed enough yet, necessarily, to make a good decision to stop. Certainly not saying that it isn't developed enough and that no people who are under the age of 24 or 25 make good decisions about drugs. In males, it's even a little bit later, ages 25 to 26. So students, the point of this is to help you understand what happens in your brain, and the longer that you wait to use drugs or alcohol, hopefully you won't, but the longer that you wait, the better equipped your brain is to make good decisions about it, and not to get the development of your brain twisted up into drug use, because then it is very, very difficult for your brain to recover, and it can never go back to the way it was before. All right. Make good choices, students. Thank you for listening.